So, good evening, one and all. So, today I'm talking about the reinforced earth structures, Module 1, Session 2. In the Session 1, we have already discussed the introduction of reinforced earth structure, what the historical background, and why the earth structure, the reinforced earth structure will be required for the soil. And in this session, so we are talking about the advantages of reinforced earth construction. So what are the advantages? So already know that the soil is weak in compression, weak in tension, and having some compression, strong in compression. That's why we are providing the reinforced strips, so like components, the strip, geogrids, geosynthetics. So there are so many materials are there, material components. So we are using as a reinforced for the earth constructions like dams, flyovers, roads. So where the soil, the property has the low property like the bearing capacity of the soil, compressibility and other parameters. So we have to increase the tensile strength or any other properties for the soil. So here so it's the advantages is the use simple and rapid construction procedure and do not require large construction equipments. So it's very simple here. Here we are providing the strips and we are providing the mesh and we are providing the linings for the soils in the different spacings in the horizontal as well as the vertical directions. The spacing is depend on the design procedure. So there is no required of any construction equipments for the construction of the reinforced earth, and reduce the less site preparation that other alternatives and result in saving area of land. So there is no required of any of the extra land for the preparation of the material preparation or any other the preparation will be required for this at the site. So directly we will provide the strips and the meshes at the site and do not need rigid unyielding foundation support easily. So directly we will provide on the soil in the horizontal as well as in the direction, in the vertical directions. We will not excavate anything, and flexibility and capability to absorb deformations due to the poor subsoil conditions where we have a less property, the less property condition for the soil. So we will provide the strips or reinforced materials for the improvement of the property of the soil. Where we have a poor subsoil, so we will provide the reinforcement for increasing the property of the soil, like poor to the rich subsoil condition for providing the reinforced, and reduced right way acquisition. Then similarly the disadvantages. So if you have advantages for improving the soil property, so we have disadvantages of reinforced earth construction also. So here we required a relatively large space behind the wall to obtain enough wall width for internal and external stability, obviously. So where we will provide the retaining wall behind that, so we will have the large space for providing the soil reinforcement, and non-availability of suitable fill material. So sometimes we are not the materials are not available easily. Suitable design criteria, corrosion, deterioration and degradation will be required. So we have to design for that the corrosion, because the soil having the moisture content, if the moisture content will be there, the reinforced will be corroded. So we have to take care about the reinforcement in the soil. The soil is not purely dried, it will have some of the moisture content, it will not should be affected to the reinforced, that result the corrosion will be occurred. Same in the case of deterioration and degradation will be there. So we should not control for that. We have to design for these three cases. So proper design will be required, and some precautions will be required for that. Design and construction practice standardization of specifications and contracting practices. And design often requires a shared responsibility between the material supplier and designer and contractor. So it will be very very important for the supplier, designer as well as the contractor. The skilled contractor, the very high practice contractor will be required for the providing the strips and the reinforcement in the soil. So that responsibility will be depend. So responsibility will be on supplier, the what the material he has to supply, and designer what the material will be required and what size, thickness. So all the properties of the reinforcement he has to decide, and contractor at the site how to provide and in what spacing. So he has to take care about that. So he has a supervision. So skilled contractor will be required. Otherwise, the heavy practice contractor will be required for the construction of that. This will be the very disadvantages of the reinforced earth construction. So here some of the limitations of the reinforced soil. So again we are talking about the disadvantages like that. So there will be a limitations also there. So here the severe and rapid corrosion of steel reinforcement is possible, obviously, where we are not taking or not take care about the precautions, or proper design will be not done. So here we have suffer for the steel reinforcement, corrosion will be there. Polymeric material degrade and when exposed to the ultraviolet rays. So we have to take care about the degradation. So already we have studied in the disadvantages, and can be damaged by rough handling on site, or by sharp stones in fill. So we have to take care about the small stones occurred in the soil. So we have to bifurcate, or we have to take care about that. So it should not be contact with the sharp stones. When constructing on soft soil, care has to be taken not to overstress the reinforcement. Where soft soil will be there, so we have to take care about the reinforcement where, so there will be a overstress. So in the continuation, the polymeric materials degrade when exposed to ultraviolet rays and can be damaged by rough handling on the site. That it will be the same thing. And here we are talking about the sandwich technique for the soil reinforcement. So what we have studied, so what we have regularly used, the sandwich technique. So example, in between two breads we have a stuff. So that will be the same thing here. So we have to provide the soils in between. So we have to provide the filler material. So it may be sand, it may be other materials. So nowadays the sand will be very popular for the sandwich technique. So regarding the sandwich technique, the test results revealed that layers of sand encapsulating the reinforcement can effectively provide an improved soil geotextile interaction. So already we have studied the sand is very important here, thereby enhancing the shear behavior of reinforced clay. The shear strength increased as the thickness of the sand layer was increased. So obviously that depend on the sand thickness in the layer. So it will be very effective with the result of shear strength. The provision of thin layers of sand sandwich, so it will be affected to the shear stress. Sandwiching on both sides of the reinforcement within clay soil, known as sandwich or sand cushion technique, and its influence on improving the strength and deformation characteristics of reinforced clay have been investigated using direct shear stress. So here, so one of the experiment has done by the researchers. See, this the first figure is that the height has taken 100 mm and the diameter it will be 50 mm, unreinforced single layer, two layer and three layer reinforcement. And in the figure B we have a sandwich technique here. The sand will be there and clay will be there and geotextile will be there. Between two clays, we have sand as well as geotextile. So this procedure is nothing but the sandwich technique. The figure B, here the clay, in between two clays we have a sand, in between the sand particle we have a geotextile. So that will be called as the sandwich, the sandwich technique. Thank you. Thank you. The session will be over and we have to continue for the next section. So if you have any queries, or already we have sent the MCQs, multiple choice questions. So please go through this and try to solve that. Thank you. Thank you one and all.